Hi, welcome to a session on grade 11 trig equations. So we look at our first question coming from the November 2019 paper, and the question reads, determine the general solution of, and I'm going to rewrite the question, which is root 2 sine x cos x, which is equal to cos x, and I'm going to immediately move the cos x to the left hand side, and that gives us a negative cos x and equate that to 0. So we want to find the general solution. The first thing we notice in the question is that we have a common factor, and you'll notice that cos x is common. So we're going to pull out cos x as a common factor. And if we take out cos x from the first term, if we divide, we're going to end up with root 2 sine x minus, if we divide cos x by the common factor cos x, we're left with 1, and that is equal to 0. We're now going to split up the factors and equate them to 0. So we have cos x is equal to 0, and we have the other solution, or root 2 sine x minus 1 is equal to 0. So immediately I'm going to root 2 sine x, and I'm going to move the minus 1 to the right hand side, and that becomes a plus 1. And we can simplify this further by dividing both sides by root 2, and that gives me sine x is equal to 1 over root 2. I'm going to get back to the first equation that I solved for, and that is cos x is equal to 0. So very quickly, a reminder of our cast diagram. We know that cos x is equal to 0, and we want to find the reference angle by using our calculators, and we'll type in shift cos 0, and that would give us 90. So remember that cos, the quadrants we are focusing on in terms of being positive, is the first quadrant and the fourth quadrant. So our reference angle is 90, and if we look at our first quadrant, our angle formula is that theta will remain as it is. And remember, we are solving for x, so we're going to get x is equal to 90 plus 360k. Or we could be in quadrant 4, and in quadrant 4 it's a 360 minus the reference angle, which will give us 360 minus 90, giving us 270 plus 360k. We can reduce this because 270 is a multiple of 90, and keep the solution on this side to be x is equal to 90 plus 360k. So looking at the other side, we want to find a reference angle. Sine x is equal to 1 over root 2, and our reference angle, if we use our calculator here, shift sine 1 over root 2, and that should give us a reference angle of 45 degrees. Now remember from our statement in terms of setting up the quadrants, sine is positive, and returning to the cast diagram, we know that sine is positive in quadrant 1 and quadrant 2. And the angle formula in quadrant 2 is 180 minus our reference angle. So we're going to end up with x to be equal to, in quadrant 1, it will be 45 plus 360k. And in quadrant 2, it will be 180 minus 45, which gives us 135 plus 360k. And there we have our solutions for this trig equations. So just to remind you, x is equal to 45 plus 360k, x is equal to 135 plus 360k, x is equal to 90, or x is equal to 270 plus 360k. And I did mention that we could actually condense this if we needed to. Thank you. We now move on to the next question. So our next question is coming from November 20. Actually, let's go to November 2017. We'll return to the other question because there's a different trick that I want to zone into. And it says, determine the general solution for sine x minus 30 is equal to cos 2x. So if we write that down, sine of x minus 30, and you'll notice there's no numbers in the front. And how do we relate sine and cos? Well, we use the co-ratios. And the co-ratio is that cos x, sorry about that, my screen just jumped. The co-ratio is that cos x is equal to sine of 90 minus x. And that is because they are complementary angles. So we're going to write cos 2x. I'll bring the question down. So in the next step, we're going to apply the complementary angle rule and change cos to sine. And the complement of 2x is 90 minus 2x. And you notice on both sides we have sine and we have sine. So therefore we can relate the actual angles, that x minus 30 will actually be equal to 90 minus 2x. But before we do that, remember in our cast diagram, we need to firstly look at in which quadrants sine is positive. And there's always two solutions. It's quadrant 1 and in quadrant 2. And remember your angle formula is 180 minus theta in quadrant 2. So we're going to drop it again. X minus 30 is equal to 90 minus 2x. So that is catering for quadrant 1. But we also have quadrant 2 to look at. And there we're going to say x minus 30 is going to be equal to, and we're going to take the 180 minus our angle of 90 minus 2x. So going to the left-hand side, we're going to carry on solving that. So we're carrying on the left-hand side, and we're going to bring our x's to one side. And if we bring our x's to one side, we end up with 3x, the minus 2x becomes a plus, and then your 90 minus 30 goes out, it becomes a plus 30, that's your 120. Now, what I forgot to bring in is the plus 360k. So we need to bring that down on both sides. I just want to create some space. So if we bring it on the other side, plus 360k, and remember we got to indicate that k is an element of integers. And if we carry on solving, we're going to get divided by 3, and bringing down your 360k, we're going to divide that by 3, we're going to end up with x is equal to 40 degrees plus 120k. On the other side, we have x minus 30, which is equal to, and we're going to apply the negative into the bracket, which it will change the sign. 180 minus 90 will give me a 90, and a minus times a minus would give me a plus 2x. And we're going to take our x's on one side, and remember we've got to bring down the 360k. So we bring our x's on one side, we're going to end up with a negative x minus 2x is equal to 120 plus 360k. and then we can divide by, or do a change of sign. And if we do a change of sign, we're going to end up with x is actually equal to minus 120 plus 360k. Since k is an element of integers, there's no need to change the 360k to a minus. And there we have our two solutions for a general solution. Okay, well, our next question is from the November 2018 paper. And if we look at the question, it says, determine the general solution. And it's 3 sine x is equal to 2 tan x. So whenever you see tan, our first option is to remember that tan x is equal to sine x over cos x. So I'm going to change tan, that 3 sine x, and I'm changing the tan to 2 sine x over cos x. And what we're going to do now is find an LCD. The 2 would go on the top with sine. So we can either find an LCD or we could cross multiply. And if we do that, we're going to end up with 3 sine x cos x is equal to 2 sine x. And then we're going to bring everything on one side. 3 sine x cos x minus 2 sine x is equal to 0. And we're going to pull out a common factor. We have sine x that's common. And that gives me sine x is equal to 3 cos x minus 2, which is equal to 0. I'm now going to split up the factors. And the first one is to say sine x is equal to 0, or 3 cos x minus 2 is equal to 0. And I'm going to take the minus 2 on the other side, giving me a plus 2. And then I'm going to divide both sides by 3. And we end up with 2 over 3. So looking at the left-hand side, if sine x is equal to 0, you'll notice we're looking at the positive quadrants. So remember our cast diagram. And sine, we're looking at quadrant 1 and 2. That's a 180 minus theta in quadrant 2. So our reference angle here, if we use shift sine 0, that will give us a reference angle of 0. And if we're looking at a reference angle of 0, in quadrant 1, our solution for x would be 0 plus 360k, which is 360k. Or in quadrant 2, we're going to say 180 minus 0, which is 180, plus 360k. And just remember that k is an element of integers. On the other side, we have to do some work. You'll notice you got cos x is equal to 2/3. And returning to our cast diagram, we know that cos is positive in 1 and 4, and in 4 it's 360 minus theta. So using our calculators, we're going to say shift cos 2/3, and that will give us x to be 48.19 in quadrant 1 plus 360k. And in quadrant 4, we're going to say x is equal to, we're going to take 360 minus 48.19, which is 311.81 plus 360k. And remember that k is an element of integers. Thank you.